Alright, happy Valentine's Day everyone. I hope you guys received beautiful gifts. And for those who are single, I wish then that next year we'll have a better Valentine's Day. Alright, so now we have a problem from related rates. Calculus. It says two automobiles are approaching an intersection on straight roads that intersect at right angles. That means that we have 90 degrees angle. Car A is traveling at 40 meter per hour and car B at 50 meter per hour. When we have 40 meters per hour and those cars are heading to the point of intersection, then the rate of change is negative because those sides are decreasing. See, those cars are heading toward each other's on an intersection. Alright, let's take the other part of the question. When car A is 3 miles from the intersection, car B is 4 miles. At that instant, notice that at that instant, which is certain time that we don't know, okay? At that time, the car A is 3 miles from the intersection, B is 4 miles from that intersection at that instant. Find the rate at which the distance is changing between the cars. And happy Valentine again. Alright, the answer says, let's write what we're given in the question. So let's call this y, which is the path of car A, and the path of car B is x. So dy over dt, which is the speed of car A, equals negative 40 meters per hour. Why? Because this side of the triangle is decreasing. We are also given the speed of car B, which is the rate of change, also dx over dt equals to negative 50 miles per hour. At that instant, x is 4 miles from the intersection, which means car B is 4 miles from the intersection, and car A, which is y, equals 3 miles. Now let's call this side, which is the distance between the two cars, z. So in the question says find the rate at which the distance is changing between the cars. The distance between the cars, which means the hypotenuse of a right triangle. So when we have a right triangle, the first thing that comes to our mind is applying the Pythagorean theorem. So since we have a right triangle, we can apply the Pythagorean theorem. So z squared equals x squared plus y squared, which leads to z squared equals 4 squared plus 3 squared, which is equal to 25. When we take the square root of 25, so z equals 5 miles. At that instant. So Z is 5 miles at that instant, X is 4 miles at that instant, Y is 3 miles at that instant too. Now, the next step is we apply the Pythagorean theorem again and take the derivatives with respect to time. Alright, in related change, or in related rates, when we derive variables, we derive them in respect to t because they are changing with time. Let's see here. So we reapply the Pythagorean theorem, z squared equal x squared plus y. Agree? We start to derive every variable with respect to t. So we have 2z dz over dt equals 2x dx over dt plus 2y dy over dt. Now, this distance between those two cars heading to the intersection, what do you think the change of this side will be? Negative or positive? Well, of course, it's negative because those sides are decreasing, so this side is always decreasing. Alright, now we have our equation 2z dz over dt equal 2x dx over dt plus 2y dy over dt. Now we plug in the values. Now we start plugging in numbers. So 2z dz over dt equals 2x dx over dt plus 2y dy over dt. We found that z is 5, x is 4, dx over dt we were already given minus 50 plus 2 multiplied by y we were given it's 3. dy over dt is negative 40, and we said why those are negative because the distance is decreasing. Now it's just a little algebra. So 10 dz over dt equal minus 400 plus minus 240. So dz over dt equals to what? Negative 640 over 10, which equals to negative 64 meter per hour. So in this type of questions, try first to find the equation and then find the variables that you were not given and then find the rate of change. And I hope that you comprehend and understood the idea and the answer of this problem, and just a little bit of humor here. We have the Valentine's heart. Okay, we have the Valentine's heart here. So mathematically the female is X and the male is Y. So everyone probably loves his partner, and of course love is a very powerful thing. And thank you.